A siphon of diameter 20 cm connects two reservoirs having a difference in elevation of 20 meters. The length of the siphon is 500 meter and the summit is 3 meter above the water level in the upper reservoir. The length of the pipe from upper reservoir to the summit is 100 meter. Determine the discharge through the siphon and also pressure at the summit. Neglect minor losses. The coefficient of friction F is equal to 0.005. Siphon is a long bent pipe which is used to convey the water from one reservoir to another reservoir when they are located in the hilly areas. In the question, two reservoirs are given. One is upper level reservoir. The water level is located here for the upper level water reservoir. This is the lower level water reservoir. This pipe is a siphon. The length of the pipe is given, which is 500 meter. From here to here, total length of the pipe is 500 meter and the diameter of the pipe is 20 centimeter. This dia is 20 centimeter throughout the length. 20 centimeter divided by 100, that is equal to 0.2 meter. Height of the summit from upper level water reservoir to water level is 3 meter. This is the summit. See, this is the water level of the upper level water reservoir. The difference of water level in between two reservoirs, 20 meters. The length of the pipe from upper reservoir to summit. See, this is the pipe connected to upper level water reservoir. Up to the summit, the length is 100 meters. The coefficient of friction is given as 0.005. In the question itself, given the condition that neglecting the all minor losses throughout this pipe. Otherwise, we get the losses at the entrance, exit and other losses, but the pipe is uniform. We cannot get the contraction and enlargement losses. So, we neglect the minor losses when considering the losses. Here, only the loss of head due to friction throughout the length occurs. We have to consider that loss only. Now, applying the Bernoulli's equation in between the water reservoirs, we know the total energy at upper level water reservoir is equal to total energy at lower level water reservoir. PA by W is the total pressure energy at this point and VA square by 2G is the velocity head. ZA is the datum head. Okay, this is upper level reservoir A, this is lower level water reservoir B, which is equal to PB by specific weight of the liquid. Pressure head at B, this is velocity head at B. ZB is the datum head. HFAB is the loss of head due to friction in A and B. We know pressure head and velocity head in the two water reservoirs are 0. Substituting these values, we get 0 plus 0 plus ZA is equal to 0 plus 0 plus ZB plus loss of head due to friction. ZA minus ZB is equal to HF. We know HF is equal to 4 into FL V square by 2ZT. Substitute the values here. 4 into F is 0.005. L is the length between AB, 500. V square by 2 into 9.81 into diameter 2GD. 4 into FL V square by 2GD. The difference between the two water level reservoirs 20 meters. 20 into 2 into 9.81 into 0.2 divided by 4 into 0.005 into 500 is equal to V square, from which we get the velocity of flow through the siphon. It is equal to 2.801 meter per second. Calculate the discharge through the siphon is equal to area into velocity. Area of the siphon 5 by 4 0.2 whole square into velocity 2.801 meter per second. Total discharge is 0.08799 meter cube per second. In liters, which is equal to 87.99 liter per second. Now calculate the pressure at the summit point. For this, apply the Bernoulli's equation in between the upper level water reservoir and summit. Write the equation: sum of the pressure head, velocity head and datum head with respect to upper level water reservoir is equal to pressure head plus velocity head plus datum head plus loss of head due to friction in between upper level water reservoir and summit point. So pressure head and velocity head is 0 with respect to upper level water reservoir. ZA is equal to pressure head at the summit plus velocity head. Substitute the velocity at summit. The velocity is uniform throughout the siphon. So velocity through the siphon is equal to 2.801 meter per second. 2.801 whole square divided by 2 into 9.81. Acceleration due to gravity is 9.81 plus ZS plus loss of it due to friction 4 into FLV square by 2ZD. We know F value and the length. Here 100 is the length in upper level water reservoir to summit. Velocity 2.801 divided by 2GD. D is the diameter of the pipe. So ZA is equal to PS by omega plus velocity head 2.801 whole square divided by 2 into 9.81 is equal to 0.399 plus HF value is 3.998. Therefore PS by W or omega is equal to the pressure head at summit is equal to ZA minus ZS minus 0.399 minus 3.988. We know ZS minus ZA is equal to, this is summit, this is upper level water reservoir. The difference between these two is 3 meters, that is ZS minus ZA. So here ZA minus ZS is minus 3 minus 0.399 minus 3.988. Pressure head at summit is equal to minus 7.397 meter in terms of water.